Hey everybody, it's Mr. Kowalchuk here. We are going to jump into Unit 8, Lesson 5, and today we are working on detour proofs. So, proving multiple triangles congruent. Now this section, I will say, can be a little tricky. So you're going to want to put the time in and make sure that you know what you're working on here. Standards, this is going to be standard 13.2. I can show triangles or their corresponding parts are congruent in context involving more than one pair of triangles. So in these situations, we're going to have a lot of different triangles showing up here. So we want to make sure that we know what's going on. We got to be careful about that. I got some strategies. Hopefully that will help you out as you're moving through these. So first off, if we say that our given, meaning the things that we're told are true, that E is the midpoint of segments AC and DB. Now midpoint means it splits it evenly in half. So let's look, we have segments A, C, and E is our midpoint. So that means that this segment here is going to be congruent with this segment right there. It's also the midpoint of segment DB. That means that it's going to be the congruent segments here and here. So now we know that DE is congruent to EB and AE is congruent to EC. So I'm just going to start jotting these down. AE is congruent to EC and DE is congruent to EB. Great. All right, so we know that. Now, what are we trying to prove here? Our end goal is to prove that triangle GDE is congruent to triangle BJE. So GDE is congruent to BJE. All right, now we got a couple things that we're going to need to do in order to sort this out here. We can't right away prove that those two things are congruent. We're going to have to kind of take a little detour around a different path in order to figure it out. So what I'm going to do with this one is I am going to concentrate first on proving triangle ADE congruent to triangle CBE. So how can I do that? Well, what I can do right away is if I were to pretend that this line GJ was not here, I would see that this whole angle right here is congruent to this whole angle right here because they're vertical angles. Then I can prove that those two triangles, the big triangles here, are going to be congruent to each other by side, angle, side. Side, angle, side. All right, so let's go ahead and state that. Triangle ADE is congruent to triangle CBE by side, angle, side. All right, so we proved that. Now, how does that help us? Well, what it tells us is that we now know a couple things. From our previous lesson, we know that all of the parts that match up in the two congruent triangles are going to be congruent to each other. So what I'm going to do is, so we don't lose track, I'm going to highlight the triangles that we're trying to prove congruent to each other. All right, so now what I want to do is I want to think about what parts in these two triangles do I now know are congruent to each other because I proved these big triangles congruent. Well, what I know is that angle D is going to be congruent to angle B. I can use my congruency statement to see that. Angle D is congruent to angle B, and I can also use my diagram. I come from the vertex down the side with 2 tick marks to this point here. I come from my vertex down the side with 2 tick marks to this point here, and I see that this angle is congruent to that angle. Well, how is that helpful? Okay, let's check one other thing out. I'm going to use a different color. And what I'm going to do is I'm going to look at this angle, DEG, right here. Now I'm just concentrating on this angle right here. I'm going to put 2 tick marks, 2 arcs there. The other thing that I'm going to do is say BEJ also matches up with that. And these two angles here are different types of vertical angles. They're vertical angles, but they're not the whole vertical angle that we use for our bigger triangle. So I'm focusing in on different angles in order to prove what I need congruent. Now, if I focus on my highlighted yellow triangles, I can see that I have angle, side, angle. And here I have angle, side, angle also. So I should probably put 3 tick marks here because I have 2 over here for that angle. Now I can say that I need to say my angle D is congruent to angle B, what we said earlier. And then angle GED is congruent to angle BEJ. BEJ. Now I can say that triangle, what am I being asked to prove? GDE. GDE is congruent to triangle BJE by angle, side, angle. And I'm done. Awesome. Multiple triangles, detour proofs. Detour proofs refer to like trying to like, maybe the problem is trying to distract me, or maybe I have to take a roundabout path to get to my end goal. Okay, so strategies. Well, what do we do about these detour proofs? How might we be able to solve them? I got a couple strategies here for you. First of all, some of the things that we did in this previous problem. Mark up your triangles. Write all over them. Mark them up with what you know is true. Use a pencil or an erasable pen if you need to, because you might need to go back and get cluttered up and whatnot. But if you do it in pen, it's going to be really hard to see your whole thing. Step 2, work backwards. Maybe starting at the end and saying, well, what do I need to do to prove GDE congruent to BJE? Oh, I need this. Well, how can I prove that? You backwards your way into the solution, and then that way, maybe you'll figure out how to break down the process. That's another possibility. Another strategy, draw your triangles separately, like we did in the previous lesson. That might help you out, seeing, oh, this is overlapping, or that's a shared side, or looking for different things. This section is very much a puzzling section. You have to take time to try to figure out what works. Or think aloud. Just like you hear me thinking aloud in the video, Mr. Hickman thinks aloud in the videos too. Talk to yourself, like talk to your dog, explain it, whatever. Try to figure it out. For me, I know that talking things out loud helps me realize what it is that's going on, and I'm able to kind of articulate in a better manner what it is that I'm trying to say or figure out. And then 5th and finally, do you have other ideas? Other ideas that work for you? If so, go with them. Don't feel like you're limited and you have to stick to just these 4. All right, so hopefully think about these strategies, see what might work for you as we tackle these next couple problems. I'm going to do 2 more, and then I'm going to leave the rest for y'all. Okay, so number 1, let's take a look at number 1 here. What do we got? We are trying to prove that YWV is congruent, or no, we're told that angle YWV is congruent to YWU. So YWV, this angle right here, is congruent to YWU. All right, cool. We know those 2 triangles are congruent. All right, well, right away, I'm seeing some stuff going on here, and I'm trying to prove that WVZ is congruent to WUZ. WVZ congruent to WUZ. So that triangle right there. Okay, so multi-step process. Multi-step process. There's a lot of overlapping here, so I'm going to go ahead and draw my 2 triangles without these lines in here. I'm just going to look at those first. That's going to be my first step to try to understand what's going on here. Okay, so I got this there. I know this angle is congruent to that, and I know this angle is congruent to this angle here. This is Y, this is U, this is W, this is V. All right, now looking at this situation, it becomes a little bit easier for me to recognize that WY is a shared side. So then in that situation, I know that WY is congruent to WY. And I can now prove that the two triangles are congruent, these big triangles. I'm kind of moving down this process here. We'll see if it works out for us. WVY, triangle WVY is congruent to triangle WUY. WUY. Phi. Do you see it? Angle, side, angle. Angle, side, angle. All right, cool. So now, why is that helpful to us? Well, what we know are a couple things. We know that this side is congruent to this side. We know that this side is congruent to this side. And we know that this angle here is congruent to this angle here. Well, I'm going back to my original diagram, and I'm going to highlight in yellow the triangles that I'm trying to prove congruent to each other. So I can kind of focus on those. Now I'm going to redraw those two triangles down here and just look at that and see what I might be able to figure out from my previous discovery of the big triangles being congruent to each other. All right, now W, Z, V, U. These are congruent and those are congruent. However, so this is the markings from my drawing over here. What did I learn from over here that might be helpful? Well, I see that these two sides are congruent to each other. And this is congruent, these angles are congruent, but they're the whole angle. So it goes beyond this. That's not really helpful. Well, what else do I see in this diagram? Because I can't really pull anything else from here that's going to help me out here. As I see, maybe you already spotted it, WZ is what? What do we call that? Yes, I heard you. We call WZ a shared side. So we now know that WZ is a shared side. Does that help us prove these two triangles congruent? Absolutely, it does. So we say WZ is congruent to WZ. And then we now know that these two triangles are congruent. And I write out what I'm asked to prove in that same order, WVZ. WZV is congruent to triangle WUZ, just like it is here, by side, angle, side. Put a box around my final answer because that's what I was asked to prove. Fantastic. All right. So in this one, the strategies that we used were thinking aloud and drawing our diagrams separately. So we got rid of some of the clutter that was in this drawing for each of the two steps that we needed. All right, now number two, given triangle AEG is congruent to CFH. All right, AEG is congruent to CFH. So I'm just going to mark this up now. I know that AE is my first two. That's congruent to CF. All right. EG is congruent to FH. EG is congruent to FH. And I also know that then these two sides must also be congruent to each other. Great. Okay. Now I also know that E is the midpoint of AH. E is the midpoint of AH, which means if this is one tick mark long, then this one also has to be one tick mark long. And GB, E is also the midpoint of GB. So if this is 2 tick marks long, that has to be 2 tick marks long also. Cool. F is the midpoint of DH and CG. F is the midpoint of DH and CG. So the same thing shows up down here, where if this is 1 tick mark, then this has to be 1 tick mark. If this is 2, then this has to be 2 tick marks long also. Okay, so far we have marked up everything that's here. And you're looking at this and you're like, but Mr. Kowalczyk, there's no proof. That's correct, I forgot to type it in there. We are asked to prove triangle GEH is congruent to triangle HFG. Okay, cool. So let's take a look at that. Get out the highlighter, triangle GEH is congruent to HFG. All right, so we're focused on what's going on here. First step, we marked up everything we know. Second step, we kind of thought through what's going on here. And I highlighted those. I've got a lot of stuff going on here in the triangles that might be distracting me. So I am going to do my redrawing step, and I'm going to draw these two triangles approximately how they show up here. And I'm going to label my points E, H, F, and G. And then we have two tick marks here. We got one tick mark here, one here, and two here. And I'm supposed to prove that these two triangles are congruent to each other. So G to E to H, if I go my directions, and then H to F to G, that way. All right, maybe you see it already. How can we prove what shortcut can we use here? 1, 2, 3. Sure, nope, I got to use 4 because I used 3 over here. So 4 tick marks right there. Shared side, GH. GH is congruent to GH. So that's a shared side. Now we can prove it. Triangle GEH is congruent to triangle HFG by side, side, side. All right, so what strategies did we use in here? We used thinking aloud. We marked up our diagram, and we drew the triangle separately that we were trying to prove. Okay, so in this one, what I want to point out is that it wasn't really a two-step process like number 1 was, where we had to take these two-step process. With this one, the detour part was we had a lot of information up here in the diagram, and it was almost like it was trying to confuse us, send us down this confusing path. If we focused on what we're trying to prove, and then we re-illustrated it right here, the side, side, side theorem, excuse me, side, side, side shortcut was pretty obvious to see. So while you're doing these detour proofs for the rest of the practice in class, just think about those strategies, think about breaking it down, and either going from a multi-step process or trying not to get confused by the busyness of the diagram. Okay, hope that was helpful. We'll see you in class and we'll move on with this lesson. Take care.